Hi again, everybody. Professor Sebastian in our statistics class notes. We are now on to page 57 of our class notes, and we're still in section 4.3 where we're learning how to predict interpret what the slope and the y-intercept of the regression equation gives us during regression analysis. So we already talked about the slope. Now we're going to talk about the y-intercept. So the y-intercept is simply the predicted value of y whenever x is equal to 0, right? Think about that. When a line crosses the y-axis, x is equal to 0. So it's just what we're going to use the regression line to predict y. So it's just the predicted value of y when x is equal to 0. Now, sometimes that doesn't mean a darn thing. It's only meaningful if it makes sense for x to equal 0. So you have to understand your data, know what x represents, and if it doesn't make any sense that x is equal to 0, then there is no meaning to the y-intercept. However, if it does make sense for x to equal 0, then you can attach meaning to the y-intercept. It is the predicted value of y when x is equal to 0. So for example, interpreting the y-intercept in our previous example, on the association between a car's mileage and its sales price, the regression equation was this: price equals 15,867 minus 0.034 miles. So that's y equals b plus mx. That means that 15,867 is the y-intercept. So that's your b. What does that mean? That means the predicted price of a car when it has been driven 0 miles, because when x is 0, is 15,867. So you ask yourself, does it make sense that a car has never been driven? It's been driven 0 miles. And I would say, yeah, sure, it makes sense. That's when you have a brand new car. It's never been driven. Okay, so that makes sense to interpret the y-intercept in that case. In our next example, example 72, got the numbers labeled wrong here, but remember that we had found this regression equation between height and weight for our sample of 6 people. We found that there was a strong linear relationship between the heights and weights in a group of 6 people. And the regression equation was as follows, right? We had weight, y, equals the y-intercept, b, plus mx. X is height. So the y-intercept is b equals minus 442.882. So if you were going to just predict that, use that value straight out to predict y when x is equal to 0, you would say that the predicted weight, y, of a person whose height is 0 inches is negative 442.882 pounds. Clearly, it doesn't make sense. Somebody's height cannot be 0 inches, and certainly their weight can't be a negative huge number, or any negative number, of course. Okay, as another example, example 73. Here's the scatter plot and regression line showing the relationship between the population size and the number of fatal car accidents for all 50 states. So we have 50 states here. We got the population of each state on the x-axis, and we have the number of fatal car crashes in that state. All right, so the dependent variable y is the number of fatal car crashes. The independent variable x, which will be used to predict y, is the population. So here is the regression equation. Fatal crashes y equals b, the y-intercept, 77.073, plus mx, right? The slope of 0.0000826 times x, the population. We had a sample size of 51 because they also used Washington, D.C. Correlation coefficient of 0.93 indicates a very strong correlation. You can see these fall nicely onto a line. Okay, so which is the independent and which is the dependent variable? That's quickly easy to see. Independent is x, that's population. Dependent is y, that's fatal crashes. Is that a positive or negative correlation? Sure, strong positive, right? Positive, uphill correlation, positive. As x increases, y tends to also increase. So describe the association. It's strong, it's positive, and it's linear. As the population increases, as x increases, the number of fatal crashes tends to increase. So y tends to increase as x increases. Interpret the slope and the y-intercept. So now the slope, y equals b plus mx, the slope is 0.000826. What does that mean? As the x increases by 1 unit. So as the population, that's x, increases by, in this case, 1 person, the number of predicted fatal crashes, y, increases by the amount of the slope, or decreases if it was negative. increases by 0.000826 fatal car crashes, right? Number of predicted fatal car crashes increases by that much. The y-intercept in this case is 77.073. That comes from the regression line equation. Y equals b, the y-intercept. So that is whenever x is 0. So when the population x of the U.S. is 0, the number of predicted fatal car crashes is that 77.073. Of course, that does not make sense. It does not make sense for the population to be 0.